In a moment, you're going to see 6 animations and 6 datum reference frames on the screen. I want you to take a minute and see if you can match the datum reference frame with its corresponding animation. In this video, I'm going to be going over how the order of precedence in a datum reference frame changes the way that a part will align in its assembly and on its gauge. And we'll talk a little bit about why it's important to select the correct order of precedence. So now that you've had a chance to watch the animations a couple times and figure out what's going on, let's go over a few of them together. And then afterwards, we will also talk about the philosophy of picking the correct order of precedence for your datums on your drawings. So we are going to start with datum reference frame ABC. And if it wasn't obvious when you were initially watching the animations, what's going on is the dark gray part on the screen is the part that we're inspecting, and the light gray part is the datum feature simulator or the gauge. So let's get into this animation. It starts off by giving us a couple of cross sections just so we have a better view of what's happening. And then we get into part distortion. So the part distorts, and this is heavily exaggerated for the purposes of the video to show how order of precedence changes alignment. So now we're going to get into the actual alignment of the part. And because datum feature A is our primary datum feature, we are going to fully constrain datum feature A. For a plane, fully constraining a primary datum means making full contact with its datum feature simulator, which in this case is minimum 3 points of contact. So datum feature A comes down onto its datum feature simulator and makes 3 points of contact. And now what's happened is we've constrained 3 degrees of freedom. So the part can only now slide left, right, forward, backwards, and spin, but it can no longer tilt, yaw, or move up and down. So now we get into the secondary datum, datum feature B. The part slides up against its the datum feature B simulator and makes full contact. And full contact in the context of a secondary datum is 2 points of contact. So now we've constrained 2 more degrees of freedom, so it can no longer move left or right or spin on the datum feature A face. Finally, we are going to move on to the tertiary datum and fully constrain the part with the tertiary datum. And the part slides up against its datum feature simulator and makes full contact. And for a tertiary datum, full contact is 1 point of contact minimum. And now we are going to see the location related actual mating envelope show up. So a small pin shows up that is perfectly located on the gauge relative to the datum feature simulator. And it expands into the part until it makes maximum contact, which in this case is 1 point. So moving on to the second animation, we're going to look at datum reference frame BAC. And let's get into it. So once again, we have our cross sections show up and then our part distortion. And then this is where things are going to change. So in the previous animation, datum feature A was the primary datum. But in this animation, datum feature B is the primary datum. So what's going to happen? So in this animation, you see datum feature B slides up against its datum feature simulator and makes full contact. Whereas in the last video, datum feature B was the secondary datum feature. It only had to make contact with 2 points. With datum feature B now being the primary datum feature, it makes 3 points of contact minimum. And then the secondary datum feature is datum feature A in this animation. So now the part slides down and makes full contact with datum feature A, which in the context again of a secondary datum is only minimum 2 points. And then finally, the part slides and makes full contact with its tertiary datum, which is datum feature C. And full contact for a tertiary datum is 1 point of contact minimum. And the final animation we're going to go over is datum reference frame CBA. And you kind of get the idea. We get our cross section of the part, we get our part distortion, and then now we're getting into the constraint of the actual part. So because datum feature C is the primary datum, we get full contact with the datum feature C gauge. And then full contact, of course, again, is 3 points minimum. Then we get full contact with the datum feature A, datum feature simulator, which again is 2 points of contact for a secondary datum feature. And then finally, datum feature A is the tertiary datum, so we get 1 point of contact to fully constrain the part. And then our location related actual mating envelope shows up and expands into the hole, making 1 point of contact. So hopefully this video made it clear how big a difference that data order of precedence can make in the alignment of a part in an assembly or on a gauge. And if we were to be making parts perfectly every time, we wouldn't need to worry about picking the datum order of precedence. We could just put them in any order and the part would align on the gauge. But because we're doing manufacturing in the real world, we need to respect the errors that are going to happen on our parts. And what I mean by that is that when we pick our datums, we can't just look at which features actually make sense to be datums. We also need to look at which ones actually constrain the part the most and which ones constrain the part the least. And this can be difficult, but doing so incorrectly can lead to parts that should have been scrapped getting passed through to assembly, or parts that should have been passed through to assembly getting scrapped. And if you feel like your company is struggling with these, feel free to reach out to Access GD&T services. We are taking clients right now, and we are experienced with datum selection, drawing stack-ups, and drawing interpretation. If you feel like working with a GD&T professional would benefit your company, feel free to reach out to me over my website.